Today, we will learn about understanding angles through intersecting train tracks. Maybe you've seen them while traveling or in pictures and videos of busy train systems. At first, they might just look like simple metal rails. But if you look closely, you will notice something interesting. These tracks form different angles when they met. That crossing point is a perfect real-life example of geometry in action, specifically intersecting lines. Now, imagine two train tracks crossing each other at a railway junction. One track runs north to south, while the other runs east to west. As these two tracks met, they form a shape that looks like an X. At the point where they intersect, four angles are created. Each of these angles are connected, and their sizes are not random. They follow specific mathematical relationships. Let's focus on one of the angles. Suppose one angle measures 65 degrees. You might be wondering, how can we find the other angles without measuring them directly? This is where geometry helps us. Using what we know about intersecting lines, we can determine the measures of the remaining three angles step by step.
But before we proceed, let's first identify the factors to consider in designing a railway track that will prevent trains from colliding. To have a safe railway tracks, we need to consider number 1, angle of intersection. Number 2, distance between tracks. Number 3, visibility and line of sight. Number 4, signal and timing system. Number 5, speed and stopping distance. But in this video, we are only going to focus on the angle of intersection. The tracks should meet at a right angle 90 degrees or a wide obtuse angle greater than 90 degrees. These angles makes the crossing clear and reduce the chance of trains sharing the same path. Going back, where do you think our problem fits to these angles? Yes, you're right. It's a wide obtuse angle. And to solve this, we use two important rules in geometry. First, vertical angles are equal. That means the angle directly opposite to 65 degrees is also 65 degrees. Second, we use linear pairs, where adjacent angles form straight line, and a straight line is always equal to 180 degrees. So we calculate 180 minus 65 is equal to 115 degrees. That means the two adjacent angles are both 115 degrees. Now the question is it safe to have these kind of railway tracks? Yes, it can be safe if the intersection is controlled by signals and the train don't cross simultaneously. However, an obtuse angle means that the train spends more time in the crossing zone. The wider the angle, the greater the overlap zone. This is why engineers must ensure enough the clearance distance and timing separation to avoid collision. This shows how intersecting train tracks are not just transportation system. They are also real-life examples of geometry. So the next time you see train tracks crossing, try to imagine the angles they form and remember, geometry is everywhere. Thank you for watching.